Monday? No? Friday? Okay, now I'll take Friday to the middle.
Okay, as you're finishing passing in, so I have your attention, finish passing in. So the goal of this whole undoing the chain rule thing is not that you learn that structure that I told you, but that you can do these fast. So if you've kind of kept in mind the whole point of thinking of it as the result of a chain rule, so hopefully ones like these, you could just write down the answer. That's what our goal is. That it's not about learning those steps that I taught you, but that those steps were to teach you about that we're really undoing the chain rule. So could you just write down the answers to these two? Try it. So see if you can do it. If you can do it, then that was the goal. That was the goal. You could just write down the answers without going through first attempt, take the derivative, second attempt. And you just write down the answer. So do you see that the x to the fifth, that's the chain part. That's the chain, and basically the g prime f is the cosine x to the sixth. So what is it?
1/6 sine x to the 6th.
So sine x to the sixth, and then we have a little thing to clean up there, which will give us, we need a 1/6. How many people got it before I started writing? Okay, fair amount. That's the goal. The goal is that there's no procedure at all. So the structure I gave you was just so you would be thinking about what these are just the result of chain rule. So can you just put it back together again? Okay. What about this one? Derivative of sine is good. You good? Yeah. So yes, if it were sine x to the sixth, it would be negative cosine. Yeah. Okay. This one. So there's our g prime. Here's our chain, right? Our chain is the derivative of the inside. There's our chain rule, the chain part. So we're going to do 1/9 ln of x all to the 9th plus c. Done. How many got it before I wrote it? Good. Okay, that's the goal. So there's this. Forget that. Okay, but so this is the most common, more difficult type of antiderivative that we see all semester. Is these that are a result of chain rule. So because we see so many of them, it's going to be really efficient for you if you can just write them down. And if you're not sure, then what? What can you do? Take the derivative and check. You can always take the derivative and check. You can always take the derivative and check, and then adjust, just like we talked about. Adjust, make a second attempt. Okay, so let's move on to the next thing. I am, thank you. But let me just check again. Yes, thanks. That's what I want. This one. Okay, the next thing is what we're going to call undoing the product rule. Undoing the product rule. So let's review the product rule. What does the product rule say? It says that if you have two functions and you take their derivative, so fg, take the derivative of f times g, we know it's not the derivative of the first times the derivative of the second. What is it? It's the first times the derivative of the second plus the second times the derivative of the first. That's the product rule. Okay, so if that's true, then if we were to do the antiderivative, we could do antiderivative of all three, and that would maintain equality. So antiderivative of the left would just be f times g. And then we'd have the antiderivative of f g prime plus the antiderivative of g f prime. So all I did here was I just took the antiderivative of both sides, or took the integral of both sides. Okay, so it's not that we'll be given a problem like the right, a sum of two, but instead it's like we're going to be given one of those. It's like we're given one of those. So the given integral, this is what we want the antiderivative of. When we look at that, it's a product of two things, but then we see that undoing the chain rule doesn't apply because it's not, undoing the chain rule has to be just right? That we have to have that chain part that's exactly or essentially the derivative of the interior. So if those don't match up, then maybe we need something else, right? We need something, maybe it's this. So the given integral is like this, and basic rules, undoing the chain rule doesn't apply. But then this one is easier. This one is one we could do with the techniques that we have. So what do? We're going to solve the one we're given indirectly by solving the easier one and finding fg and then just subtracting. Okay? So we're gonna think of the given integral as one of the resulting terms of the product rule. We'll determine what f and g are. And then we're going to compute that easier antiderivative, and then we'll solve for this indirectly. So in this equation then, what will the red one equal? The red one will equal what? So we're going to use the green easier integral and fg. What does the red one equal in terms of those other things? Very easy algebra stuff. Please. Right, we'll just subtract. We'll just subtract the easier one, and then f times g minus the easier one will be the one we want. You see? So we're not really ever going to do that integral. We're going to do a different integral and subtract it from f times g, and that's equal to the one that we were given. Do you see? Doesn't make sense. So this one that we're given is going to be equal to fg minus the easier one that we compute, and that then will be the one we were given. Okay? So let's try this. Here we go. There's the instructions again. So the first one we'll do is this. Try this. Before we do, so here we come. So here comes this integral that we have to find the antiderivative for, okay? And the first question we're always going to ask is, does undoing the chain rule apply? That's always going to be our first defense. This thing we've been working on for a couple days. Does undoing the chain rule apply? Yes or no? Okay. How could you make one small change to that so that it would be undoing the chain rule? Everyone think about that. I want to make one small change to that integral so that it would be an undoing the chain rule. Could you do it? Everyone try to think what would that have to look like so that undoing the chain rule would apply? Anyone think they got it? Yes, sir. He wants cosine x squared. I see a nod. Yeah, that would be the little change you could make. If it was cosine x squared, you see now undoing the chain rule works. Why? Because our chain, the f prime, is the x. Or 4x is, we can take care of factors, no problem. But because it's not x squared, it's simply cosine x. Can't do undoing the chain rule. All right, so this is a job for undoing the product rule. We're going to think about this as this integral as this right here. And we're going to figure out, so what do we want to do? We want to figure out what f and g are, and then solve the easier, hopefully the other integral, g f prime, is easier. And if it is, then we're home free, right? We're just going to do f times g minus the easier integral. So we got two things here. We got 4x, and we got cosine x. And one of those is f, and one of those is g prime. So the question is, which is which? So at this point, you don't have any way to know because you're not experienced in doing this. But that's okay because there's only two possibilities. So you can try one, and if you walk it out and it's not working, then you go back and try the other way again. Okay? But let me suggest this. What are we going to be doing? Eventually we're going to find f prime, and we're going to find g. And we want f prime g to be an easier integral. We want f prime g to be an easier integral. So what makes, we take x, what's the derivative of x? Just 1, right? And so that makes it easier, right? So should x be f or g prime? It should be f because when we do f prime, the x goes away. You see that? So if I make f, I'll just make it the 4x. And the g prime cosine x. Then what is f prime? 4, easier, right? Easier. And what is g? So now this is like a little antiderivative that we have to do. Cosine x is a derivative, the antiderivative of cosine x's sine. So now, is g f prime an easier integral? Is it doable? Yes. So that was the right choice. Put the 4x with the f and the g prime with the cosine x. So now we've got f times g. So we're just going to follow this product rule formula. And over here on the right is f times g. So it's going to be 4x times sine x equals, I'm going to call the r given integral a for the answer. A for answer. So that's what this is, the one we're trying to find. Plus, so we got an easier integral, sine x times 4 dx. And so then how do we solve for the answer? A equals what? This minus this. So this just stays as it is, and then what's the integral of 4 sine x? That should be an easy one by now. Antiderivative of sine x is negative cosine. So we're going to have negative 4 cosine. So simplifying, 4x sine x minus a minus plus 4 cosine x, indefinite integral plus c. Or improper, is it? Indefinite. Improper, indefinite. Okay, did you see what happened? Doesn't make sense. So what are we doing? We're confirming that it's not undoing the chain rule first, and then we suspect that it's this undoing the product rule. So then we have to know which of those two factors is f and which is g prime. And so there's only two possibilities. So we could do one or the other and then walk it out. If we get an easier other integral, then we know that we've taken the right path. Any questions before another example? Okay, let's try this one. Okay, same thing as before. Could it be the result of chain rule? Could this be undoing the chain rule antiderivative? If not, can you make one small change so that it would be? Make one small change to this so that it would be undoing the chain rule. Everyone think about it. Make one small change so that it would be undoing the chain rule. How many people think they got it? It needs to be more. If we know undoing the chain rule, then we know what that would have to be undoing the chain rule. How many people think they know what that small change is to make it undoing the chain rule? Oh, you break my heart. Joseph, what is it?
E to the 3x cubed.
He wants e to the 3x cubed. That's right. Why? Because this now would be like the chain. This would be the f prime, essentially the derivative of this interior function, 3x cubed now. But only x cubed would make it work for undoing the chain. Any other exponent on that x, that first x here, you couldn't do undoing the chain, right? Okay, so now we're going to go for, I'm going to say, undoing the product rule. So we're thinking that the given integral is one of the two terms of the product rule, and we're going to look for an easier integral and solve indirectly, right? Solve indirectly. So if this is this, then one of those things is f, and one of those things is g prime. And what's our goal? An easier integral. Our goal is an easier integral. So what do you want to make f? X squared, because when we take the derivative, it's going to be a lower power. So we're going to do x squared. G prime is. Okay, so what is f prime? 2x. What is g? So now we have to do a little antiderivative on the fly here. Antiderivative, given g prime is 3x, g is? Okay, so we know it's going to be essentially e to the 3x, and we're going to need a 1/3. Okay, and so we've got our, I'm going to rewrite this over here. So f times g is going to be x squared times 1/3 e to the 3x equals our answer plus new integral g is 1/3 e to the 3x times f prime 2x dx. So now we come to this one. So it's easier. It's one less degree of x. Is it undoing the chain rule now? Yes or no? Is that undoing the chain rule? What would it need to be undoing the chain rule? What would this power have to be right here? Squared. It's not squared. Okay? It's 1/3 e to the 3x times 2x. So it's not undoing the chain rule. It is easier than this one, it seems, like lower degree. How are we going to do this one? How are we going to do that if it's not undoing the chain rule? I'm going to apply this again. Now I got to get this one. Here, I'm going to apply this technique again. Think of it as its own problem. And look what's going to happen. That 2x is going to go down a degree again, and I'll have one I can do. 1/3 e, or whatever it is, something e to the 3x is one I can do. So I'm gonna repeat now. So now this is going to be, I'll do it in blue. this is now going to be the subject of a new subproblem, right? A new subproblem. So for this, we're going to have, and I'll do capitals now. Capital F, capital G prime, and then F prime and G, so we don't get confused. So what am I going to choose for capital F? So I'm doing this subproblem in blue. What am I going to choose for capital F? 2x, G prime, 1/3 e to the 3x. F prime is 2, G is. So antiderivative of e to the 3x is just going to be e to the 3x. And I have a 1/3. We're going to need another 1/3, right? We're going to need another 1/3. So it's going to be 1/9 e to the 3x. If I lose you, please ask. If I lose you, please ask. Okay, so now I'm doing this subproblem here. What is it? It's going to be f times g. I'll write it out. Capital F times g equals integral at capital F g prime plus f prime g dx. This is what we're working on right there. That is this here. So that right there is going to equal, I'm going to call that, so I'll call that B this time. Okay, so B equals capital FG minus this one. So it's going to be 2x times 1/9 e to the 3x minus this integral f prime 2 times g 1/9 e to the 3x dx. Okay, and so what were we after? We're after that original thing a. So a is going to equal x squared minus 1/3 e to the 3x minus all of this. That's our solution or our answer to the blue box, right? So we'll go back here and we'll say now our answer equals little f times little g, x squared times 1/3 e to the 3x minus this one. And this one is our B, is our blue box. So it's going to be minus, parentheses, 2x, 1/9 e to the 3x minus integral 1/9, 2/9 e to the 3x dx. Okay, so we got one more step is to do that last integral and then apply it to a little algebra. But before I do that, so did I lose anybody? Did I lose you? Did you follow? Please. Nice and loud. Yeah, this is our A, right? A is the integral that we were given. So A is this minus this, the easier integral. And the easier integral was the result of the technique again. Was that this thing down here? You follow it? Yeah. So this is what? This is B over here. So this whole thing here is our B. Okay. Here we go. So now we got it. So x squared, 1/3 x squared e to the 3x minus 2/9 x e to the 3x. Okay, now this is going to be minus a minus is going to be plus. So antiderivative of 2/9 e to the 3x is one we can do, right? Antiderivative of e to the 3x is e to the 3x. But we're going to need a 1/3 for that, right? Multiplied by the 2/9, so to be 2/27 plus c. Got it. So it takes 2 iterations to get that x squared down to just power 0, right? So the first iteration gets it down to x to the first. Then we do that subproblem. It gets it down to x to the 0. And we can finally do the integral. Yes, please.
So basically, we're trying to get the power down to 0.
Often. So we'll see some other variations on this, but that's a very common use of the undoing the product rule. Is you'll have like a trig or a e function times x to something, and you're trying to get that x. You're working that x down to the power 0, right? Right.
Okay, so do you know how like the back part is like f prime times like the integral of f prime times g?
Yeah.
Can we do like the opposite, like f times g prime?
No, because that's what you're given, right? That's the one you have. You're doing f. You want to find f g prime. You do that indirectly by finding f prime g.
What if you switch both?
That's just switch. Then it's the same thing. You're just switching the symbols. You're saying start with g f prime and then g.
Oh, okay, that makes sense.
You're just switching the symbols. It's the exact same thing. Yeah. Other questions? Okay, so what's the most common forms you're looking for where this applies? So let's list those. Okay, so you can be on the lookout for them. And last chance questions on this one. Okay, so here are the most common antiderivatives for which this is the way to do it. So, like the first one we saw, so x to the n sine x or cosine x. Whenever you have just sine or cosine times x to a power, that's going to be a good indication that you're going to use undoing product. Okay? Same thing with exponential functions. Like the one we just saw. We had x squared e to the 3x. Same thing. So x times e to the something x, or x squared times something e to the x. Okay? Just plain old natural log. You're gonna work on that one next. And then same thing. So a monomial of x times ln of x. But actually, so this doesn't take repeated iterations though. You can actually, no matter what the power is, you're able to do this in just one step. Okay? So on those, you'll find that if you set things up correctly, this just takes one iteration of this approach, and you can get it. You don't have to do it n times. Okay? For those with sine or e, you have to do it whatever n times or n minus 1 times, whatever it is. I guess n times. Okay, so I want you to see if you can find the antiderivative of natural log of x. Find the antiderivative of natural log of x. If you get stuck, get some help. Okay, if you get stuck, help. Got that? You can do this. Do this one. For those who are still struggling on this, I'll start putting the solution to this first one up on the screen. But if you got the first one, then do this. Integral sine inverse x. Integral sine inverse x. Work on that. So I did part of the ln x one. I did part of it so you can look. If you got it, then do sine inverse. So once you get the natural log, this is very similar. The approach is very similar. You got to know your derivative of sine inverse, which is 1 over square root of, I'm going to do it. Here's what you get when you do sine inverse. Many of you have discovered this. So here's our quote-unquote easier antiderivative. How do we do that antiderivative? So hopefully we recognize now. How do we do that? Do you see that this is undoing the chain rule? Because where's the chain? Where's the f prime? There's the f prime. Essentially, that is the derivative of what's inside this. So it works for undoing the chain rule. So there's your g prime f. Power negative 1/2 is your g prime. Power negative 1/2. You got your f prime in the top. Then you solve for a indirectly. Okay, I want to start one more just to, yeah, we got time. So you finished that one. You finished those two on your own. Hopefully you got all the tools you need if you didn't finish them yet. New example. Okay, first question, is it undoing the chain rule? T cubed over the square root of 4 plus t squared. Is it undoing the chain rule? There are two possible small changes you can make to make it undoing the chain rule. So what are the two possible small changes you can make to this so that it would be undoing the chain rule? Go. Everyone do it. Everyone do it. What are the two possible small changes you can make so that undoing the chain rule works? What's one of them? Someone new. Yes, sir. He wants the t squared to be t to the fourth. Yes? Got it. What's the other small change we can make in the black here? Just take the cube away and make it t to the first. Does it work? That's it. T to the first would work, and then on the top, and then 4 plus t to the fourth in the bottom. Those would both be possible changes, but we don't have that. Okay, so we're going to look for what's f and g prime. All right, so but in the past we've done this. We said, okay, we'll make that to the t cubed, and then this will be the 4 plus t squared. Okay, derivative is easy, 3t squared. So now how about this antiderivative? 1 over 4t squared to the, or 1 over radical 4t squared. It's not because it's a square root and it's got a 4 there, not a 1. So okay, it's not arctangent. It doesn't work. It's too far removed from arctangent to get it to be arctangent.
Isn't it arcsine of 2t?
No, arcsine is 1 minus t squared. So we got 4 plus. And we need 1 minus for arcsine. Okay, so maybe let's flip it and try it the other way. This doesn't work. So 1 over radical 4t squared, and then t cubed. Derivative would be negative 1/2 4 plus t squared to the negative 3/2 times 2t. And this antiderivative would be 1/4 t to the fourth. And now we're going to do the integral of those, the product of those. So what are we going to have? We're going to have 1/4 t to the fifth over. So the first way didn't work. Did this way give us an easier integral? Negative? No, that's positive in the denominator. How about this? How'd we do? Worse, right? It's worse. It's not better, it's worse. So it didn't work. So it doesn't work if we do the t cubed as f, it doesn't work. If we do the t cubes as g prime, it doesn't work. So we need some, and earlier in class I said these would be the only two ways to do it, right? One term as f, one factor as f, the other factor is g prime. But that was then. This is now. So there's got to be something else we can do here. Doesn't work. Ah, shoot. So does anyone see, there's a trick to this. Does anyone see what we can do to make this work? Very good. For what? For all right, so we've got to do an antiderivative here, g prime to g. So what can I pull out of this whole thing that we can do an antiderivative of? She said, just t over square root of 4 plus t squared, because that would be undoing the chain rule, right? And then what would that leave for F? T squared. Tricky, right? So you got to split the t's apart. Just take as many t's as you need to be undoing the chain rule with that square root. One power of t. And then what's left for F would be t squared. This works. You can finish it on your own. Now this works. So now you can do a little undoing the chain rule to get g. Your F prime is 2t. And then that's one that's you can finish. Okay, so I'll post a web work. It'll be due next Wednesday, but then after Monday's class, we'll add to that. Okay, so we're going to Friday and Monday's material all to be due on Wednesday.